Welcome back, guys. Today is Thursday, May 14th, and today is a good day because it is your last day of notes for this year. Yay, last day of notes for geometry. Today we are going to be finding measures of segments that intersect in the exterior of a circle. So remember yesterday or Tuesday we talked about segments that intersect inside of a circle. This time we're going to be talking about segments that intersect outside the circle. So there are a few cases where this can happen. This first one is two secants intersect in the outside of a circle. Then the product of the measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant segment and its external secant segment. So fill that in and let me show you what this means. So for example, if you have this figure where you have two secants, so remember a secant passes through a circle at 2 points. So this first secant passes through the circle at point B and point C. The other secant, this one down here, passes through the circle at point D and point E. These two secants intersect at point A, and point A is outside the circle. So whenever you have a case like this, we know that the product means multiply. We have to take the whole secant, which would be AC, times its outside piece, which would be AB. That should be equal to the other whole secant, AE, times its outside piece, AD. So how I like to remember this is that we take the whole times the outside, set it equal to the whole segment times the outside piece. So whole times outside equals whole times outside. Let's try this in an example. So these are two secants because they pass through the circle at 2 points and they intersect outside the circle. So I know that I'm going to set it up whole. So let's focus on this secant segment first. The whole segment would be GJ. The outside piece would just be HJ. Now we're going to look at the other secant, LJ. The whole secant segment is LJ. Whoops. And we have to multiply that by the outside piece, which is just KJ. Next, what you do is you plug in the values. So GJ. It doesn't necessarily have something written down for the entire length of GJ, but we can find it by adding the two segments together. So x plus 8 should be equal to GJ. HJ we know is equal to 8. LJ we can find by adding together LK and KJ. It's like segment addition. KJ is 6. To solve this, we multiply it all out. So on the left side, we need to distribute. 8 times x gives us 8x. 8 times 8 is 64. 16 times 6 gives us 96. Now to solve this, I need to get x by itself. So the first step is subtract 64 on both sides. So I get 8x equals 32. Now I'm close to getting x by itself, but it's still multiplied by 8, so I have to go ahead and divide by 8 on both sides. So on the left side it cancels to give me 1, and on the right side I have 32 divided by 8, which is 4. So I just found x equals 4. There's a practice problem on the top of the next page. Before you do it, pause and see if you can do it on your own. All right, here are the solutions. For my CC kids, if you didn't get part A, that's all right. I wouldn't expect you to know or remember that exactly off the top of your head, but maybe you might remember factoring. The difference on part A for all of you is that we got x squared when we distributed. Whenever you have an x as the outside piece, it's going to be a little bit more difficult because you get x squared. But you should still know how to solve this. You should have learned how to solve this in Algebra 1. So to solve an equation when you have x squared, so if you have x squared plus 9x equals 36, the first step is to set it equal to 0. So you subtract 36 on both sides to get it equal to 0. Once you get it equal to 0, now you can think, what two numbers multiply to give me negative 36, but add up to positive 9? Those two numbers would be negative 3 and positive 12. So I can factor it out like that. And then once I get it factored out, all I have to do is set each factor equal to 0 and solve it. So I've solved this one by adding 3 on both sides. I solved the other by subtracting 12 on both sides. Obviously, x could not equal a negative number because a segment could not be equal to a negative length. So I know that my answer has to just be x equals 3. You should have all gotten part B correct. If you are in my CC class, you may skip this part and skip down to where I'm telling you about the homework. For my CP and honors students, I need you to keep watching this video. All right, so here's the next type of problem where the two segments intersect outside the circle. So you could also have a tangent and a secant intersecting in the exterior of a circle. Here's what you know. The square of the measure of the tangent is equal to the product of the measures of the secant and its external secant segment. Let's talk about what this means. So if you had this figure here, JK is obviously the tangent because it's only intersecting the circle at one point. JM is the secant because it's intersecting the circle at 2 points, L and M. So what we know is that it said the square of the tangent. So what that means is tangent squared. So JK squared is equal to the secant, the whole secant segment, so that's JM, times just the outside piece, JL. You can still think of this as whole times outside equals whole times outside. Because think about it, JK, the whole segment, is JK, and the outside piece is also JK. So when you take JK times JK, you get JK squared. So you can still think of it as whole times outside equals the whole times the outside. Let's use it in a problem. This says find x. So we know that we need to take the whole tangent, so PQ, times the outside piece, which is also PQ, so you could also write this PQ squared, is equal to the whole secant, SQ, times the outside piece of the secant, which is RQ. Now let's plug in our values. PQ is equal to 8. SQ, we need an expression for. It would be 7 plus x. RQ is x. Now let's see if we can solve this. 8 squared is 64. On the right side, we need to distribute. X times 7 is 7x. X times x is x squared. Now to solve this, since it has x squared and x in it and a constant, we first set it equal to 0. So we do that by subtracting 64 on both sides. The next thing I would do is rearrange this so that we have our x squared first, then 7x, then minus 64. So there's a couple of ways to solve this. We could try solving it by factoring, but I don't know about you. I can't really think of two numbers off the top of my head that multiply to give me negative 64, and also the two numbers add up to positive 7. I don't know any two numbers that do that off the top of my head. So another option on how to solve this equation is using quadratic formula. I'll write quadratic formula over here off to the side for you. So remember, for quadratic formula, we do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's talk about what these a, b, and c numbers are. The coefficients of of our x squared is equal to a. So in this case, a equals 1. The coefficient of x is equal to b, so b is equal to 7. The constant at the end is equal to c, so c equals negative 64. Notice we don't take the x squared or the x, and we have to use the positive or negative sign in front of the number. So let's go through and plug these in. So we have x equals negative 7 plus or minus the square root of 7 squared minus 4 times a times c over 2 times a. So if we want to simplify this, the first thing we have to do is follow PEMDAS, so parentheses first. Technically, there is an imaginary parentheses around this numerator and another imaginary parentheses under a square root. So we have to take care of what's under the square root first. So we get x equals negative 7 plus or minus the square root of, now we can square our 7, 49. Now we can multiply 4 times 1 times negative 64. Well, it's actually negative 4 times 1 times negative 64. That gives me plus, let's see. Let me do this on my calculator. I can't do that in my head. 256 over 2 times 1 is 2. Now, I can combine 49 and 256. That gives me 305 over 2. So from here, there's nothing more that you can simplify. So we're going to plug it into our calculator. The first thing you're going to plug in is negative 7 plus square root of 305 divided by 2. Or the next thing you could plug in is negative 7 minus radical 305 divided by 2. So when you plug these in, we'll get x is equal to about 5.2 or negative 12.2. Obviously, x cannot be a negative value, so I know that x has to be 5.2. Go ahead and try the practice problem to the right, pause it, and then resume and check your answer. Here's your homework for tonight. You have Goal 14, page 754. You have numbers 10, 12, and 16. For my CC kids, you can skip 12 and 16. These are for my CP and honors only. Because those go over those two problems we just did. So CC, you're skipping 12 and 16. Everyone is doing 10, 12. Well, everyone in CP and honors, you're doing 10, 12, 16. And then your reflection question is number 26 in the book. CC, you're just doing 10 and 26. Have a great day, guys. I hope you are doing well. This is our last day of notes, so this is my last video. So I hope you've kind of learned something, maybe, hopefully. These have been hard to make, but I've enjoyed making them for you. I hope to talk to you again soon. Bye.